morning, everybody. My second time at this summit. I'm pleased to be back talking about smart networks. So I work for Vodafone. I'm responsible for their fixed connectivity products. I'll give you a bit of insight into Vodafone and our enterprise solutions. So let's start at the bottom of the slide. Our vision is to be the world's leading total communications provider to enterprise. We've got a significant fixed and mobile network infrastructure, over 1 million kilometers of fiber, presence on about 80 cable systems, 75 country MPLS network. In our markets, we have national networks, fixed and mobile, 17 countries, as well as a Pan-Africa network as well. 4G, key to Vodafone, available on net in 13 countries as part of our WAN solution. We're a top 5 global ISP. Now, on top of that infrastructure, we provide our network products and services, and today's presentation is informed by our Ready Network. This is the on-demand, software-defined network solutions for the enterprise. And you can see the types of products, and we were referring before to SD WAN. That's one of several products in this portfolio that we'll touch on. They enable the digital enterprise, they integrate total communications, and you can see at the top some of the examples of those different types of communication that can be connected together over our Ready Network. So, I thought I'd sort of change the scene a bit. This slide makes me think about what was the first piece of music that I listened to and how did I do it. Think about yours. Mine was on vinyl. I think it was either U2 or Spandau Ballet. But yeah, it got me thinking back. We quickly moved to tapes. I could play things on different devices. I had a bit more capacity. But really, capacity and quality was resolved by the CDs. Now, we're streaming. So hasn't music changed? I can listen to what I want, when I want to, all different types of music. You're saying, has he gone mad? Why is he talking about this? Well, I think there's a lot of parallels with the evolution to smart software-defined networking. If you think about it, the products, let's think network products, firewalls, routers, they're changed in the same way. They're moving to software. The consumption model's changed as well. We're consuming them from the cloud, just like streaming. We don't need to go in the shop. They're not delivered to our sites anymore. They're just downloaded. Everything is changing. And I guess for us, our Spotify or iTunes moment is the evolution to smart software-defined networkings. This is our evolution, and there's so many parallels with the music industry. So business communications are changing quickly, and I think these are the sort of catalysts that are driving the need for software-defined WAN. We've got cloud adoption. The WAN needs to be more agile. With that comes security concerns, just like mobility. And all of these things are driving more and more traffic onto our networks. The networks need to be more efficient. They need to deal with the next big thing, be it robotics or artificial intelligence. They need to always deliver the right user experience, the right application experience every time for the enterprise. With all these different demands on the network, the only way to do that is through software-defined. So let's have a look at some of the technologies. And this is sort of a very simple overview. So start with the software-defined network. For me, this is automating the configuration of physical networks to meet business outcomes set by you, the enterprise, for how your application should perform, how users should experience those applications. Network function virtualization. So taking physical network functions, typically have their own devices, routers, firewalls, application performance management, delivering them through software. These things, these technologies, enable virtual customer premise equipment. We only need 1 or 2 devices to connect to the WAN now at our sites. And onto those devices, we can download functions or access functions in the cloud. The software-defined WAN, securely connecting the enterprise locations in the cloud over a variety of paths, mobile, internet, MPLS. to meet those application user experience policies that we set. SDN complements SD WAN because it controls the physical networks in between. It allows bandwidth on demand and other on-demand services. And then we've got the automation of service delivery. Much quicker turn-up of sites, much quicker turn-up of functions. We believe in Vodafone that over the next 10 years or so, 75% of IPVPN MPLS networks will migrate to SD WAN and these types of products and services, and you can see why. Let's have a look at some business applications. So firstly, the increasing cloud adoption. It's interesting, we have traditional WAN here, but still a lot of today's networks look like that traditional WAN. And what's happening? The branch sites are sending traffic to the data center to connect to SaaS services. The data center is connected to the internet through a dedicated internet access circuit. More and more traffic is going over MPLS. It's becoming more expensive for the enterprise. And all traffic destined for the cloud is going via that data center. So it's adding latency. We then saw the evolution to hybrid WAN. A number of enterprises have adopted the hybrid WAN. So internet could be broken out locally from the site rather than going over the MPLS network. And we saw Cloud Connect services, direct connections from MPLS networks to cloud providers to deliver a secure, high-quality experience for mission-critical cloud services. Problem with this, though, is the complexity. I've got all these different routes into my site. How do I manage that environment as a customer? And that's where SD-WAN comes into its own. It automates that complexity for the customer, moves to an application experience. You've got a view across the network of your applications and how they're performing all the time. So you get the efficiency of the hybrid WAN. You've got a much more dynamic, application-driven network experience. Business case, clear. Cost reduction, better experience, and a network that's ready for the cloud. There's other opportunities. Virtualization of the branch. We look at the traditional branch today, lots of devices, different vendors, different devices, management. Here we're showing Vodafone's software-defined WAN product. It's called VPN+. And you can see the efficiency opportunities. Let's look on the left there at the branch. We can consolidate those different hardware devices into a single device now. But there's different models. Here we're showing in the first branch a single compute appliance, a universal CPU. And onto that device, we can load routing, firewalls, wireless LAN access controllers, whatever it happens to be. Or we can access functions in the cloud over the Vodafone network. The alternative is if I'm a customer, I've got my own compute, well, Vodafone can terminate the WAN connection on what we call a FinCPE. It's SDN compatible, connects to the WAN, but functions sit behind it on the customer's compute. Then some customers say, well, I want to use my existing network and move to an SD-WAN. My existing network, Vodafone, isn't with you. Well, we've got a solution. We can put our virtual CPE, Fin or Universal, behind the existing physical CPE and start to refresh that network and transform it to the customer to a software-defined WAN. Those functions are no longer from one provider, one vendor. They're multi-vendor. So customers got flexibility, they've got agility, they're not tied to one vendor and their roadmap. They can innovate faster. Another great opportunity for SDN, NFV, and smart networks. Now for the network team, the ability to control and have visibility of what's going on is so important. The old world still exists for many of us. I've got bandwidth, I've got quality of service, but I deal with all the routing, I deal with the applications, etc. New world, I get much better visibility. I can also set thresholds and alerts. So if my applications are starting to degrade, I know about it, I can see it in the portal, it's communicated to me through text messaging, etc. Policy management. Across all my estate, I can deliver a consistent experience securely. I can prioritize how applications perform, which routes they go over into my site as well, to deliver the right latency or quality of service experience. And if I want to roll out new applications, I can do that rapidly through a portal or another means of control. A lot of our customers are talking to us about APIs at the moment. We're moving to the on-demand environment. What does that mean? Well, I can turn up a new branch myself as a customer. I have the device shipped to me. I authenticate it off the portal. Off I go in a matter of days. Think about music model being transformed for delivery. So too is the WAN in a big way. Turning up those services instantly, and I can configure settings myself as I want to as a network manager. The control is now with the customer. We're seeing a lot of demand also for very high capacity services. These are some of the applications that are driving it. Let's start with the MRI scans. I'm always fascinated by this. I think 4 minutes to send an MRI scan between locations is just about acceptable. But you need a 10 gigabit connection to do that. So I think if you're using 1 gig, it takes 40 minutes. These types of bandwidth intensive applications are driving demand for high-speed optical Ethernet. Not only do you get higher speeds, but you get known routes, low latency performance. Vodafone can offer this between 26 countries. We've also got national solutions in market. We've introduced more granular speeds on our service. So you still get known routes or deterministic transport between locations with the right latency, but rather than ordering 10 gigs, you could order 4 gigs and scale to 10 when you want to. Much more flexible, much more cost-effective for our customers. Why is this relevant in the new world? Well, these types of network are becoming software-defined. So software-defined networking controlling the transport allows customers to flex speeds, to turn up connections between data center when they want to for their applications. And for me, there's a blurring between a software-defined network and a software-defined WAN. Software-defined WAN controls networks between endpoints at different customer locations. SDN controls the network in the middle. And over the next 3 years, we'll see the two come together so customers have an even more efficient dynamic network solution. I thought this was an interesting slide to put up for the procurement teams out there, just to understand how the pricing structure differs. So here we're showing a typical MPLS pricing structure and Vodafone's software-defined WAN product, the VPN+. So, from an access perspective, my costs fall. I've got access in both instances, but on the SD WAN, I'm using internet. I'm using mobile, not just MPLS. I have port bandwidths, maybe less so on MPLS, more on internet now. But if your provider can combine SDN with SD WAN, those port bandwidths support bandwidth on demand as well, which can be more efficient. Then we've got the possibility of quality of service. With Vodafone, it's inbuilt into the SD WAN. We're selling an application experience, you get the quality of service you need. That's the norm, I believe. Router situation changes. I've now got virtual CPU. I can consolidate those different hardware devices into a single device. I do have an additional charge. It's the SD WAN charge, of course. I could just pay a license. I could pay a management fee to my provider or my systems integrator. And then I've got the opportunity with virtual functions. So things are changing, but overall the TCO is better for the customer. How do you transition to these software-defined WANs? 3 typical scenarios that we see in the market. Routers are end of life, but I'm not quite ready to move to SD-WAN. How do I future-proof? Well, what we can do is deploy virtual CPU that's SD-WAN ready with a traditional MPLS network. Customer then could start to consolidate and take advantage of network functions, virtualized, and then upgrade to SD-WAN, soft upgrade, no more upheaval at sites, it's just a soft upgrade when the customer is ready. Scenario 2, I'm ready for SD-WAN, I want to use my existing routers. There are solutions that are compatible with Cisco routers, for example, that allow customers to run SD-WAN on existing devices. It's a neat option, it's an easy transition. And in time, you can then refresh and move to network function virtualization. And the third option, My existing routers are not compatible. What do I do? Well, you can deploy, as I was showing earlier, virtual CPE in place of existing routers, move to SD WAN, or behind or in front of those routers, depending on your setup. There's lots of ways to transition to SD WAN. You don't have to wait to end of contract with your provider. The opportunity is here and now. It's going to be driven by cloud, digitization, those trends that I was talking about earlier. The transition, very straightforward. So what should you consider as an enterprise? What are your next steps? Well, understand which projects are going to have a major impact on your network. What's your strategy going to be in consequence? Do you know what devices are connected in all those different locations? Audits become important. Do you understand your applications going over your network? If you're going to move to a self-serve environment, what does that mean for your operation? What about the commercial changes that have to be thought through? Am I comfortable with bandwidth on demand and consumption-based networks as a customer? Understand what's available from different providers. Do you go to an over-the-top provider? Would you manage it yourself? Would you need SI support? Do you go to a network operator who combine the physical networks with the SDN NFV, a single solution, end-to-end managed, end-to-end SLAs? Lots of choices to be worked through. So Vodafone has the Ready network. This is our SDN NFV portfolio. It's combining our extensive fixed and mobile networks with the agility and efficiency of these new technologies. We're focusing on 5 pillars for our investment. The first one is so important to us, leveraging our network. And I'm very excited about some of the mobile use cases that underpin our new software-defined network products. A good example is every virtual CPE we deploy in Vodafone markets has an inbuilt 4G SIM as standard. That's there as a path of last resort, gives the customer a higher site availability. But there's other things we can do with mobile as well. We can do rapid turn-up of sites. We can deploy mobile service within 2 days. We could provide comms quickly using mobile ahead of fiber. So again, we enable comms for the customer when they want to in time. I think mobile's quite powerful. As we move to 5G, it's going to transform our SDM products because we introduce quality of service on 5G using a technology called network slicing. So we can prioritize applications over that technology as well. And that's going to be quite different and innovative for our customers. It's all about connecting to the cloud. There's a choice of public cloud providers and Vodafone private cloud solutions over our networks. On demand, innovate at speed. Multi-vendor is so important to this. We're not tied to a typical SD WAN vendor, not one. There's several you can choose from Vodafone, dependent on your requirements. And it's the same with the virtual functions available over our networks. Multi-vendors, best of breed to meet your requirements. For me, that gives you faster innovation, more flexibility. And we're designing a very open API-based architecture that allows us to integrate these different services together, connect everything digital for our customers. A more efficient network solution, high levels of control, and as I was saying, very easy to transition to. That's Vodafone Ready Network. We're combining our physical and mobile networks with SDN NFV for the enterprise, moving to smart networks. This is our evolution. Thank you for your time.